All right, trigonometry, math 112, BMCC. Let's take a look at what trigonometry is. And this is related to sections 5.1 and 5.2 in our textbook. Sorry, I've got two mice here, my magic board, my regular mouse. They were in conflict for a second. So trigonometry is about triangles, angles, and circles. So I'm going to attempt to draw a circle here. Wish me luck. Hey, that's pretty good. All right. So here's my circle here. And what I'm going to make believe here is that the center of this circle is the origin point here. So I'm going to have a circle with center. Zero, zero. And then I'm going to say that point up there is when y is 1. And this point over here is when x is 1. And if that's the case, then this better be -1 down there. And this better be when x is -1 over there. And so I'm saying that this circle has a radius of 1. So if I draw some kind of random radius out from the center here, let's say that one right there, then I get a new point on the circle over here. And the distance from the center to that point right there is right, that's the radius. That better be 1, otherwise this ain't a circle. When I make that radius there, there's a few things that I think are important. And those important things are that that point has an x value down here and a y value over here for that point. Right? So here we have x, here we have y. So this is some point x comma y on that circle. Other thing that happens when I make that radius is in trigonometry, we often identify the angle from the closest part of the x-axis to that radius. I'm going to call that theta. There are other angles, right? There's the angle from the y-axis over to that, but it is useful sometimes, but it's not the most important angle in trigonometry. I could find the angle from this side of the x-axis over to there, and sometimes we will, but again, that's not usually the most important angle in trigonometry. Right, so there's lots of different angles I could get from a part of the x or y axis to that line, but typically that angle theta that I pick there is from the closest x-axis to the radius. And this version of the angle that I'm picking is also called the reference angle. So AKA also known as, okay, so reference angle. So that's the angle theta we pick most of the time. There are other angles that we could pick with respect to the radius and one of the axes, and sometimes we will, but almost always we'll be more interested in the reference angle. So that's important too. Cool thing, and this is the big connection between the circle, the triangle. You might say, wait a minute, I don't see a triangle here. There is a triangle here. If I take this point and I connect to that closest x-axis here, and then I consider the point from the origin over to that point right there, I've made a right triangle there. Okay. And if you think about plotting the point xy, when we plot points, often we say, all right, let's go right or this direction for x, and then we say, let's go that direction for y. Okay, there's the point. So there's two ways I can identify this point xy. One way is simply just to say, hey, there's the x value, there's the y value. But the other way I can define this particular point on the plane here is I can tell you what the radius is and then I can tell you what the reference angle is. And if I do that, then you can get there too. So if I say, hey, go 30 degrees off the positive x-axis and then head out from the origin 1 unit, that's going to put you right there, right? So that's another way to define this point. And trigonometry is essentially the connection between these two. So one set of coordinates is just to say, hey, x and y. But I can also have a different kind of coordinate system where I say, use a radius and an angle. And a place that actually kind of comes up is, you ever seen a movie where there's this radar scope going around? It's like a weird screen, and it's usually the radar is like a radio tower that spins, sending out a signal as it's spinning, and then it blips when the radio wave bounces back. It'll make a little blip there. And that thing just keeps spinning round and round here. Right, so the radar thing spins from the center here, and then it blips when it reflects off something. Say, hey, there's an object out there, well, look out. Right, so think about planes flying in the sky. They use radar to detect where they are. We use GPS more than that now, but still radar is a thing. So it's just another way to identify points on the plane or points in space. And that's what trig is all about. Now, if there are two ways to identify that point, then I should be able to state like a formula for how to get x if I know r and theta, or how to get theta and the radius if I know x and y. Right? So that's the next big thing we're going to look at. So I'm going to bust that out in a new picture here. So let's just focus on the triangle for a moment, and then we'll get into some circle stuff. So in that circle, I ended up with this right triangle right here. So I had this right angle there, and I said this side right here, that's the up part, right? So that's my y. This over here, this leg on the bottom, that was my x, and then I have the r up here, and then I had my angle theta. So those are the three variables I found, and I can identify this point right here. If I say this point over here is the origin, in two ways. I can say it's, again, the point xy, or I can talk about it in terms of the radius, that's a semicolon there, and the given angle. And so the trigonometry version of connecting these trigonometry says that this x value right here, so this distance horizontally, is equal to the radius times what we call the cosine, COS, of the angle, right? So this x value depends on two things. It depends on the angle we made, and it depends on the radius that we're working with here, okay? So my x value is a function of the angle and the radius. And so here's my equation for that function right here, right? So you've played with functions. Here, instead of y as a function of x, I got x as a function of r and theta. And for this simple example, we're saying that r is equal to 1. Well, multiplying by 1 is kind of lame, so that since here I'm on a circle of radius 1, I can just say, all right, in this case, x is just the cosine of theta. But if we have a different radius, we do have to consider it. So that would be on what we call a unit circle. Unit means radius equals 1 unit. The y value, that's a similar thing. To get the y value here, I would take the radius times what we call the sine, sin, and the sine needs to know the angle to get a number. And since this is a unit circle, radius is 1, I can more simply state 1 times the sine is the sine. And the sine is just some magic function on our calculator, but we'll learn more about it as the quarter goes on. And so this would be, again, on the unit circle. So those are the important parts I wanted to get to at the moment. And again, this is stuff in sections 1 and 2. We're going to back up a sec to section 1. And again, if you have a question as I move along here, feel free to put it in the chat or speak up. And make sure my chat is visible. Quiet at the moment. All right, so that's kind of an overview of the big, what trigonometry is, and we'll dive more into it. It's simple at first, but it's pretty complex when you start using it. So back to my circle, and we'll play with a few different circles today. Let's hope I do as good as last time. No, not really. Last one was better, but we're going to go with it. So again, I'm assuming that's my center right here. Is at the origin. And then I'm going to say that's x equals 1. That up there is y equals 1. And so if this is a circle, that better be x equals -1, and down there y equals -1 over there. And then I am going to pick radius. Ooh, that wasn't very straight. That's better. So we have a radius equal to 1. So anytime I identify a point on the circle and I connect that point with a segment to the origin, that again is a radius, distance from the center to any point on the circle. And that point right there is x, y. Now, again, once I name that point, I have an x and a y value. If I wanted to get to that point, often the way we plot points is to say, all right, from here, let's go over whatever x is, and let's go up whatever y is to get there. And when we do that, we make a right triangle. So because I named that point xy, I've coincidentally made a right triangle. Important thing here, in this class, you should draw pictures like this every day of either a triangle or a circle and a triangle. If you don't, that means you're not doing the math right. So please, do good math, draw pictures. Now, what do I know about right triangles? When I think of right triangle, I think, man, the Pythagorean theorem was hammered into my head about right triangles. So let's take a look at that. And the Pythagorean theorem actually was a picture with a whole bunch of words. When they discovered this several thousand years ago, humans did, they didn't write things down the way we do today. And there was this stone tablet that said, behold. And what they said is, if you have a triangle with a right angle, they use different terminology, and you measure the legs, okay? So we have the legs of a triangle, and the legs are off of the right angle. And the Pythagoreans said, measure those legs. Okay, so let's say I measured one leg, I call that measurement A. I measured the other leg, I called that measurement B. They said to then look at the squares of those legs and add them up. And what you're always going to get is the same thing as the square of the hypotenuse. And they usually call that one C. All right, so if I have two sides and they happen to form a right angle, and we measure one side A and the other side B, and we square those leg measurements, and then we add them up, then what that's always going to give us is the same as the square of this bigger side here, C, the hypotenuse. Oops. So hopefully that is very well drilled into your head by your previous life in math. And again, we got legs. So this guy and this guy right here, and they're always off that right angle there. And then this one right here is my hypotenuse. So if I compare the Pythagorean theorem to my picture here, well, here's my right angle. I have a leg here that measures whatever x is. I have another leg here that measures whatever y is. And then the connection, the longer side here is that 1. So according to the Pythagorean theorem, I measure x, I square it. I measure y, I square it. I add those up and I get 1. So this, based on the Pythagorean theorem, must be the equation of the circle. So let's test it out. You're going to need a calculator for this class. In the intro video, I recommended a few different calculators. So let's go take a look at some calculators. Zoom out of my way. All right, so one of them that I demonstrated yesterday is called Desmos, and hopefully you've used that. Oops, that's the scientific one. We'll come back to that. Let's get the graphing calculator. So Desmos has a graphing calculator. Desmos has a scientific calculator, and it depends on what I'm doing. So like on my phone, I have the Desmos scientific calculator. So if I'm not at a computer, I'm going to whip up my phone and use this app. It looks pretty much just like this, but it's a little narrower for my computer screen, my phone screen. Can I graph on Desmos on my phone? Yeah, but it's awkward. Don't like that. Another online calculator I use a lot, and I'll be using this in class occasionally and sending you links to things I make in this, is called GeoGebra, which you may or may not have seen in the past. And in my opinion, Desmos is trying to be GeoGebra. GeoGebra has been around a lot longer. And GeoGebra has a bunch of different things. They have their graphing calculator, which is a lot like Desmos with a few other bells and whistles. I like the geometry version for this calculator, but they're all pretty darn similar, the graphing calculator or the geometry calculator from Desmos. So I think today I'll use their graphing calculator, and you should see it looks like Desmos, but they got some extra buttons here that make it a little easier to use. So I'm going to demonstrate each of these today. All right, so first thing I'm going to do here is, oops, I'm just going to type X. To get a power, you could either bring up the keyboard down here, or you could just do Shift-6, which gives you that little hat key on the keyboard. And then you can type your square. Then you have to arrow out of that and do the plus. Otherwise, the plus ends up in the power, which is not good. And then Y, I'm going to just type Shift-6 to get that little hat key, the caret squared equals 1. And then Desmos says, hey, that looks like a circle to me, right? Desmos graphs all of these points right there for me. And so I now have that circle on the screen, and I can zoom in on it, and I can click on it. And when I click on it, it gives me a point, and I can see the coordinates of that point, which is kind of neat. And it also automatically calculates intercepts for me. So I can see it calculated the x-intercepts, it calculated the y-intercepts for me, and displays them on the screen, which is kind of nice. All right, I'm going to do the same thing in GeoGebra. Works pretty similar. I just type x raised to the second power. Did I type that right? Yep. And I can also come down here and get a power. So they have those quick buttons in view. I have to arrow out of the power plus y to the second equals 1. And so it does a similar thing. And it also labels the intercepts for me. And I can click on them. GeoGebra has a few other features that I really like in their tools section. And so, for example, I can stick a point on the circle right there, and then I can move that point around. So that point is stuck to the circle, which is kind of fun. And I'm going to build this up a little more, and then I'll share it with you. Let me zoom in on it. Other thing I want to do here is I want to connect a line segment from the origin to that. So now if I go back to the move tool, I can grab the point and the radius will move too. It's kind of fun. All right, I go back to the algebra screen, and again, you're not required to use this, but I find it a pretty useful tool for doing trig stuff. I can solve all kinds of problems here to check my algebra to see if it matches. For point A, I'm going to go to the settings and ask it to show me the value of the point also. All right, it gives me a ton of decimal places, but I can see that as I move that point, right, its coordinates are going to change. Now, as I move the point and the radius, the reference angle here is also changing. So I'm going to draw that in here too. And once I do that, I'll share this out with you guys. So let's see, I want to measure an angle. And let's see, it says select 3 points or 2 lines. So again, you get instructions when you click on something. Select 3 points or 2 lines. So I want to say, I want to measure the angle from this line here to that line there. And so it draws it in there. So now when I move the point, I can see, oops, I got to go back to the move tool, that I can see the angle changes and the value of the X and Y change. And so we're going to look at that in another calculator in just a second. But first, I'm going to sign in here and share this with you. And for those of you looking at this video in the future, this link will be in the description of the YouTube video. This is what's, let's say, units, circle 2. I made one yesterday too. Save, and then here's the link. So I'm going to put this link in the chat. So if you bring up your chat, for those of you who are live with me right now, you can just click that link and it will bring up this page. Now, when I do share stuff with GeoGebra, it's going to share whatever was on my screen at the moment I hit share. Once I do something after that, like if I take this point A and I move it into a different quadrant, you won't see that. You'll just see it where it was when I shared it. And if you come back to this later in the future using this link and I added more to this, you will, however, see that. So it's kind of like a Google Doc in a sense, that when you go to the link for it, you get the newest version of it, which is kind of neat. So what's the point here? The point I was talking about is, what is trigonometry? And trigonometry is the relationship between the angle that's formed between the radius and some measuring point, in this case, the positive x-axis, and the x and the y value. The x value we call the cosine of the angle. You can't have a cosine without an angle. So if you say, what's the cosine? My response is, well, what's the angle? Right? They go hand in hand. This y value is what we call the sine of the angle. So let's see if I can get some nicer numbers. And oh yes, let me put it in the right spot. Let's go to algebra. And then can I force that angle to be something? No, it's not going to let me. Bummer. All right, let's suppose I get this. Give me something nice. Okay, 30. Can I get really close to 30? Not exactly. That's not bad. So this says 29.8989. So I'm just going to go to another calculator and show that relationship between this angle here, and I'm going to pick the x value. So GeoGebra says, and let's zoom in on that again, that this angle is about 29.8989, and the x value is about 0.86691-ish. So I'm going to go over to my Desmos scientific calculator, which has this sine cosine button. It's in degree mode right now, and either we can be in degree mode or radian mode. I'll talk about radian mode later. So I'm going to take the cosine, and the angle that GeoGebra showed me was 29.8989. Now, I didn't type all of those digits, right? I only typed the first 4 decimals. So I'm not going to get exactly this x value up here, but I'm going to get close to it. Let me see if I can make that a little bigger in case that's hard to read on your screen. Let's try size 18. Let's go 20. All right, hopefully that's a little more readable. So let's see, I entered 29.8989, I ignored all those other decimals, and I should get a value that's about 0.8669, and my scientific calculator says 0.8669. Hey, I got close up to the nearest, what, 10th, 100,000, 10,000, 100th, that's to the nearest millionth with 4 decimal places here. I have a pretty accurate result here. If you pick a different angle, you'll get a different x value. So again, what's the cosine? Cosine is relationship between the angle from some reference line to the x value, the horizontal value of the point on the circle. And that's one of the big things about trigonometry. Okay, next. So that's kind of the overview. What is trigonometry? Sines, cosines, circles, angles, x's, and y's. A circle is related to the Pythagorean theorem. So let's look at that some more.